Good morning, everyone. I'm Amey Joshi. I'm here to give a seminar presentation on real-time LiDAR processing for drivable region segmentation using FPGA under the guidance of Professor Dr. Arun sir. So I will give you a dilute introduction about this paper. Autonomous driving has been growing rapidly from research experiments to commercial vehicles. There has been explosive research progress going on in the artificial intelligence and in machine learning. It is very important for the autonomous driving research to know the traffic sense. There are some sense perceptions like the drivable region, object tracking or detection, traffic light or traffic sign detection. So these tasks controls all the autonomous vehicle. There are some diversities due to appearance. Also, the changing shapes and the lane markers and the camera lens distortion and the clarity due to occlusion or blockages or illumination sometimes. Visibility condition also diversifies due to weather. So the author suggests there can be two inputs, that is LiDAR and camera, and the processing will be done on the FPGA. So this CNN algorithm is used here, which feeds millions of data and processes it onto an FPGA. So here the author has suggested using of embedded platform so that the data will be processed in real time and will be fed to the system. These are the literature surveys the author has referred. From the first paper, he has referred the LO DeepNet, from which the convolutional neural pipeline will be detected, will be used. From the second, the CNN-based road segmentation he has taken. From the third, the flexible data and usage of TensorFlow has been used. Whereas in the third, it is nothing but the object detection, that is the pedestrian detection in deep neural network. So the scope of this paper is to develop autonomous driver assist by detection of drivable region segmentation using LiDARs. The convoluted signals from the LiDARs will be taken and processed it on in an real time on an FPGA, that is on an embedded system. So how does this everything works? Like how does LiDAR and other processes are done? So the author has taken LiDARs. So why LiDARs? LiDARs are nothing but light detection and ranging. The 3D geometry of road perception, including the drivable region, can be detected using LiDAR. So the 3D geometry is taken into three coordinates, that is x, y, and z, and the target surface as named as R. The LiDAR scans the range in n numbers, that is it scans at the rate at r upon 60 per second. The lane detection will also be processed using the LiDARs. Object detection and tracking will be individually marked, that is every moving object and any non-living stationary objects will be given different colors, like I shown in the previous slide here. So every light, street light or road signs or any moving object or any living thing will be given different colors to segment out every object differently. So he has used CCN. So why is CCN needed here? CCN is nothing but convolutional neural network. It is used for image recognition, classification, for example, object detection or face recognition. The computer sees it as an array of pixels, and it depends on the image resolution. So machine learning is used in this. So to is for segmentation of the road. Mathematical operations are performed using CCN. So the programming part, that is very hectic and very use programming is required, will be cut off by the usage of CCN. So the high level of abstraction can be done using the convolutional neural network. So the image will be taken in height, width, and dimension. That is in the RGB matrix. That will be converted into a smaller grayscale image. That not like if you take for an example, the height width will be 6 cross 6 and the dimension will be 3. Then it will be converted into grayscale. That will be 4 4 4 cross 4 cross 1. So it will be easier to detect. The input of the LiDAR point will be pre-processed and given into an array, and the network will be used into a network output map by processing it onto a chiplet, and the process route post result will be shown on the camera on the screen. So the processing unit here the author has suggested is the real time NVIDIA. This processing unit can process each LiDAR scan in 17.5 milliseconds. So why does the processing GPU is needed? It is because it uses less power and it is suitable for embedded devices. It is used for parallel processing and can be customized according to the specification of the customer. This is the overall block diagram. The author has suggested Xilinx ultra scale platform. It scans LiDAR frames transmitted at 10 Hz using a UDP protocol. CCN architecture processes at 12.59 milliseconds, and the block, that is the embedded system, will consume power of 12.594 watt. So these are the references I have mentioned the author has used. From the first paper, he has used the histogram, that is the camera plus LiDAR 3D horizontal image processing. From this, in the second reference, he has taken the usage of height, that is what will be the height of the object, like how high the coming object is. And from the third paper, he has taken the road marking, that is the boundary of every small objects that is at the macro device. Yeah, thank you.